Hello everyone. This is a review for unit test number 2. What we're about to do is go over an instance of problem set number 2. And to prepare for unit test number 2, you must take problem set number 2. Note that it is a mirror image of unit test number 2, so there's no surprises. Basically all that happens is the numbers change. So you want to take problem set number 2 as many times as needed. And my math lab will only keep your best score. So don't worry about scoring lower the second or third time you take it. My math lab will keep your best score. And I am going to require that you score at least 50% on problem set number 2 in order to take unit test number 2. Because otherwise I feel it's almost pointless, because if you can't score 50% on the problem set, then chances are you're not going to score 50% on the unit test. So 20 questions, and take advantage of some of these simple ones in the beginning here. Here's a full page of solving linear equations, and the first example I'm going to rewrite p minus 6 equals 20. And remember, we want to isolate the variable, add the opposite, zero it out, undo it, however you think of it. In order to isolate the p, we're going to add 6 to the left side. We'll line up the equals, add 6 to the right side. And there's the addition bar. The 6's are gone. We'll bring down the p, tuck it right in next to the equal sign. And 20 plus 6 is 26. So that's all there is to that one. Moving on to letter B. Again, I'll recopy. So these first two problems, they're just one-step problems. That's the addition property of equality. Now the multiplication property of equality. So we have to get at x, and we understand that the negative 5 is being multiplied by x. So to undo multiplication, we're going to divide. And just remember, when you divide both sides of the equation by the coefficient of the variable. Not the variable, just the coefficient. And the sign is dividing both sides by negative 5. And we get that x is positive 7. Okay, now this example involves a fraction as the coefficient. And as we saw, there's two methods. Either the reciprocal method or the cross multiplication method. And I'm going to choose to use the cross multiplication method. If you like the reciprocal method, feel free to use that. To use the cross multiplication method, what you want to do is let the x express the left-hand side here as a single fraction, not as 2/3 times x. That is, express it as 2x over 3. So in a sense, the x is being absorbed into the numerator. Because that's really what it means. It's really x over 1. So if you multiplied them as fractions, you'd get 2 times x over 3 times 1, or 2x over 3. And then the right-hand side, I'm going to make a fraction. It's a whole number. And I'll make it a fraction by expressing it over 1. And then from there, we can think of cross multiplication. So 1 times 2x, 2x. 3 times equals, remember, right when you take the cross product, you want to write down an equals right away. And then the next cross product, 3 times 12, 36. And then it's just a division. So we're going to divide both sides by 2. And x is 18. Okay, and so take advantage of the easy ones here. Here's a two-step process. This is basically combining the concepts of questions A and B. Remember, if the variable is on one side, you want to bring the constants to the other side. Again, I'm going to recopy 2x minus 7 equals 15. Okay, the variable is just on one side, so I bring the constants to the other by transposing the negative 7, adding 7 to both sides of the equation. And we get that 2x is equal to 22. and now the division. So it's a two-step process. Constants to the other side, then division. And in this case, we get x is 11. Okay, and then we have when the variable is on both sides of the equation. And when the variable is on both sides, remember, it's your choice. You have to decide what side you'd like to bring the variable to. And I know that most people are comfortable bringing the variable to the left-hand side of the equation. But if you recall the guideline, and I'm going to use it here, I'm going to recopy this. The guideline is to bring the variable to the side where the coefficient is greater. And the coefficient of, where the coefficient of the variable is greater, I should say. And the coefficient of the variable is greater on the right side. So therefore, if I want to move to the right, the variable, I'm going to subtract 8x from both sides of the equation. And then on the left, the 8x's are gone. I bring down the -3, line up the equals, and 10x minus 8x is 2x. And then we bring down the +7. So then if I bring the variable to the right, I want to bring the numbers or the constants to the left. So we now need to transpose the +7 by subtracting 7 from both sides. And -3 and -7 combine to give -10. Recopy the equals, bring down the 2x, and these 7's are now gone. And now it's just a simple division. So we're dividing both sides by 2. And x is -5. Okay, in the next question, we see a set of parentheses. And remember, you want to always first remove the parentheses by the distributive property. So on the left-hand side, there's really nothing to do. So we'll just recopy -4y plus 8. But on the right, by the distributive property, we will distribute the -4. And multiplied by 2y, we get -8y. And then distributing that -4 to the +3, we get -12. And now we have a situation just like letter E, where we have the variable on both sides of the equation. We have to decide to bring the variable to one side, and in this case, the coefficient -4 of the variable y is greater than, on the left-hand side, is greater than the coefficient of -8. So therefore, bringing the variable to the left, where the coefficient is greater, we can add 8y to both sides of the equation. And for -4y plus 8y is 4y. Bring down the +8, line up the equals, the y's are gone, bring down the -12. And now if we have the variable on the left, we want to bring the constants or the numbers to the right. Get rid of the +8 by adding the opposite, transposing, undoing, however you think of it, zeroing it out. And we get that 4y is equal to, combining a -12 and a -8, we get -20. And then finally the division. And we're dividing both sides by 4 here. And I'll just use these zeros to finish it up. And so therefore y is -20 divided by 4 is -5. Okay, so letter G looks the same as letter F, but something interesting is happening here. Because when we recopy the left-hand side, and the equals, of course, we're going to distribute the 8 as normal. And remember, if you just see the x, it's understood that it's 1x. You can slide a 1 in there if you like. And 8 times 1 is 8, so 8 times x is just 8x. And then we distribute that 8 to the 3, and 8 times 3 is 24. And now you might notice something a little peculiar, and that's the fact that the variable on both sides of the equation is the same. And so if you tried to bring the variable to one side, no matter which side you decide to bring the variable to, you would have to subtract 8x. But when we subtract 8x from both sides, the x's on the left are gone, we get 9, and that's equal to the x's on the right are gone, and we get 24. So there's a statement that is obviously not true. 9 is not equal to 24s, so that's false. So remember, this is the special case where if the variable vanishes on both sides of the equation, there's two possibilities. Either the statement is true and our solution is all real numbers, or, as in this example, the statement is false, and then the solution is that there is no solution. So there's no solution, there's no value of x that will satisfy that equation. So that's what you want to report for a situation like that. And then letter H is a classic. Has to do with the distributive property, and the second step after the distributive property, as we will see and as you should recall, is to combine like terms on either side of the equation. So to begin with, the distributive property, we're going to have to recopy this 7y. The plus 4 is distributed times y gives plus 4y, and multiplied by negative 6 gives negative 24. We recopy the equals, and we distribute this 5 times y is 5y, and then 5 times 1 plus 5. Remember, you have to put a plus in between to separate the terms. Now, the closure of the parentheses stops the distribution, so we just simply recopy the negative 4. And then recall what we said. Before you start to transpose, that is, move things from one side of the equation to the other, the worst case should be something like letter E. That is, where there's a variable and a constant equal to a variable and a constant. I always use the general expression, and I say ax plus b equals cx plus d. Worst case, if you want that, and then you can start to transpose, and then the worst situation you have at this point would be the three-step process. So what I'm saying is, after we remove the parentheses in this example, we want to combine like terms on either side. The equals is our barrier, and we can only combine like terms on either side of the equation. So looking at the left side, we see a 7y plus 4y, which can be combined to give us 11y. We're going to have to recopy the negative 24 and the equal sign. And on the right side, well, there's no other y's, so I'm going to recopy the 5y, but we can combine a positive 5 and a negative 4 to get positive 1. Okay, so now we have the situation where that's our worst case, variable and a constant equal to a variable and a constant. It's our three-step process. Remember, it's most advantageous to move the variable first, so therefore I'm going to subtract 5y from both sides of the equation. I want to move the variable to the left in this case, and subtracting 5y from both sides, showing it explicitly, as hopefully you are doing as well. We get 6y minus 24 equals 1. And if the variable's on the left, we want to bring the constants to the right. So undo the negative 24 by adding 24. And we get that 6y is 25. And then finally we can divide. So dividing by 6, we get y is 25 over 6. And that cannot be reduced. There's no common factor between 25 and 6. and so therefore we just leave it. We prefer improper fractions, so we'll leave that as it is. So fractions can be solutions to these equations. Okay, so now moving on. So right there, that's 40 points of the exam, just knowing the fundamentals of solving linear equations. Then we get to some word problems. And I'm going to keep these simple, so just take advantage of the fact that they're not going to differ greatly from what we're seeing here. And when you experience the problem set, they will be very similar to what you will see on the unit test as well. And so here we're given a situation about a number. So some number has this little property here in the sense that this sentence has to hold true. You can let, if you want, say x equal the number, but that does not necessarily need to be stated, but it is helpful because you're going to talk about the number in terms of x. And so just break it down. It says 4 times a number, so that part of the sentence means 4x, 4 times a number, minus 9, so subtract 9. Okay, so far what do we have? We have 4x minus 9 is equal to, so that's our equal sign, and then 3 times the number, so that would be 3x, and then plus 3. So 4x minus 9 equals 3x plus 3. And now that we've set up the equation, we can solve for x. And this is our 3-step process. Typically, when the variable's on both sides, I'm going to choose to bring the variable to the left because 4 is greater than 3. So I'm going to subtract 3x from both sides. Well, 4x minus 3x is 1x. There's no need to write the 1. You could just write x, and then, because the 1 is understood, of course. The minus 9 is brought down, bring down the equals. Those x's are gone, and we get 3. And we bring down the 3, that is. And then if I brought the variable to the left, I want to bring the constants or the numbers to the right. So we're going to add 9 to both sides of the equation. And so the 9's are gone, bring down the x, tuck it in next to the equals, and 3 plus 9 is 12. So typically the equations that result from these word problems are actually quite simple to solve. Okay? It's the setting up of the equation that you have to be careful with. And number 3 is probably, it seems like one of the hardest questions because it looks like there's a lot of verbiage there and talking about 3 pieces of this piece of steel and the relationship between the 3 pieces. But my math lab actually breaks it down for you. First off, what you always want to do is let x equal the first piece, or typically it's going to be the shorter piece, okay? But we'll just say let x equal the first piece. Now before I fill in the rest of this, let me just start by saying, okay, I want the second and the third piece now in terms of x. You might want to make a sketch. And the nice thing that you're going to notice in my math lab is that they actually do this sketch for you. So take advantage of this. That is, the entire board here, or piece of steel that is 38 inches long. And we're cutting it into 3 pieces. So maybe the smaller piece, a little bit bigger piece, and then the biggest piece. So the first, second, and third pieces. And you don't have to draw them to scale or anything, but we're going to let x equal the first piece. So this is going to be x. And then it says the second piece is twice as long. And that's all there is to it. It's just twice as long. So if the first piece is x, twice as long as that is just 2x. And then we have to be a little bit careful here when talking about the third piece. It's 2 inches more than 6 times the first. Okay? So 6 times the first piece is 6x, and it's 2 inches more than that. So therefore 6x plus 2. And the nice thing about my math lab is this particular question gives you this diagram. Okay? So take advantage of it, because they basically did all the hard work for us. That is, x is the first, 2x is the second, and 6x plus 2 is the third. So now the sum of all those pieces have to equal the total length of the pipe, or of this piece of steel. So that is x plus 2x, and then plus 6x plus 2 has to equal 38. So there's your first piece x, second piece 2x, and the third piece 6x plus 2 has to equal the total. Now before we solve for x, and this is why it's going to be very important for you to show your work and submit it through Blackboard, because if you get to this point, you've done a good amount of the work, and if you make a careless error with your computations, then seeing this work, I will be able to award you with the majority of partial credit. Okay, but before we start transposing, remember, juggling terms around, we want to combine like terms on either side of the equation. And I slid a little 1 in there in front of the x, because I want to combine the 1x, the 2x, and the 6x to get 9x. Then I recopy this plus 2, and that equals the 38. And then we want to solve for x. It's the variables on one side, so numbers on the other. Subtract 2 from both sides. And we bring down the 9x. That equals 38 minus 2, 36. Finally divide by 9. And we have that x equals 4. But make sure that when you solve these, you go back and you claim what all these pieces are equal to. So the first piece is equal to x, which we found to be 4. The second piece is 2x, so that's 2 times 4, or 8. And the third piece is 6x plus 2, so 6 times 4 plus 2, and 6 times 4 is 24, plus 2 is 26. And then you could actually verify that this is true, that you did things correctly, because if you add the 26, the 8, and the 4 together, you do get 38 inches, okay? So you can almost double check your work there. Alright, and then we get to what we call literal equations. Well, I'm sorry, not literal equations. This is substitutions with formulas. So we're given formulas that relate variables, and we'll always be given the values of all but one of the variables. And so I'm going to rewrite the formula, A equals BH, and then we're just going to make our substitutions. So that's all there is to it. You just substitute the given values of the variables, and then you solve for the unknown variable. So A was given to be 120, so substituting into our formula with 120 equals B was given to be 40, and then that's the B is being multiplied by H. I replaced B by 40, so I could just simply write 40H. And then I want to solve for H, as mentioned in the directions. And so that would just require a division. We're going to divide both sides by 40. I'll just finish it up here. So it looks like H is 3. Okay. And similarly in number 5, we have the same type of situation where we're given a formula and we're given the values of all but one of the variables. And so we're going to make our substitution. I think I'll recopy this on the right here again. P is A plus B plus C. And make the substitutions. P is 30. That's equal to A. That's what I'm looking for. Oh, there's a little mistake. That doesn't happen very often. This actually should have said solve for A. So you can make that correction. But it's kind of obvious because we're given P, B, and C, and in the equation the only thing left is the A. So we'll recopy the A, and then plus B is 7, plus C is 12. And then before we can solve for A, let's first combine the 7 and the 12 to get 19, so 30 equals A plus 19. And now to solve for A, transpose the positive 19, zero it out, add the opposite, however you like to think of it. And looks like we get 11 equals A. Okay, and so the next thing is to solve what we call literal equations. And I think, yeah, I'm going to wait on that. We'll stop this video. We'll do a part 2. And we'll pick up with the question number 6. So when you're ready for part 2, we'll see you then.